Hello, this is Professor Kuehn, and welcome back to Introduction to Astronomy at Wisconsin Lutheran College. In the last few lectures, we've been going through some of the selections from Aristotle's book On the Heavens. We've gotten up to his Book 2, chapters 13 and 14, which is what I'd like to talk about over my next few lectures. By the way, this is contained in a Student's Guide to the Great Physics Text, Volume 3, Chapter 4. At the beginning of this chapter, in the introduction, I provide some overview of the geocentric celestial sphere model that we've been talking about. This is the mechanical model that Aristotle was employing in understanding or accounting for the motion of the stars, the moon, the sun, and the planets. That's what I talk about in the first few pages, just reminding you about these celestial spheres that are rotating and carrying the planets and the sun and the moon. In this chapter now, beginning on page 30, this is Aristotle's chapter 13 of his book 2, Aristotle begins to recount and then to refute some of the ideas that many other ancient philosophers had regarding the shape and the location and the motion of the Earth. So let's jump right into this. I think this is very interesting, by the way, before we get started, because Aristotle takes the positions of previous thinkers very seriously and then begins to argue against them and in favor of his particular view. So here we go. He says it remains to speak of the Earth, of its position, of the question whether it is at rest or whether it is in motion, and of its shape. So he begins by talking about the position of the Earth. And he says that it is at the center of the world. Remember, the world is a term that's being used for the universe. So he says the Earth is at the center of the world. But many other people see it in a different way. Although many people saw the Earth to be at the center of the world, some of them saw the Earth to be at a different location. So for example, the Pythagoreans, which he mentions part of the way down this paragraph, take the contrary view. They think that there is a fire at the center of the world, and that the Earth is moving around this central fire a bit like one of the planets. And in addition to the Earth moving around the central fire and the planets moving around the central fire, there are also perhaps one or more counter-Earths that are also rotating around this fire at the same distance from the fire as the Earth, but maybe exactly on the opposite side of the fire, so we wouldn't be able to see them as we're going around. Now, what is the reason that the Pythagoreans give for their views? Aristotle goes through some of the reasons. The first reason, he said, is because the most precious thing, which is fire, belongs at the most precious place. Okay, so let me just write this. They present this in the form of a syllogism, by the way. A syllogism is a kind of argument where you have two premises and then the conclusion follows if you accept those premises. So the way that the Pythagoreans argue that the fire must be at the center is, first of all, they say the most precious thing, so this is like leg 1 of the syllogism, the most precious thing, which is fire. So the most precious thing belongs at the most precious place. Okay, so that's leg 1. Leg 2 is the most precious places are the circumference and the center of an object. So if you have a round thing, the center and the circumference are the most precious places. And finally, I guess this is a three-legged syllogism, he says fire is the most precious thing, or the Pythagoreans say this. Okay, and if you put all these together, you will conclude that fire must be at the center. Okay, now you might argue with any of the particular assertions that are being made in this. You might disagree with the most precious thing belonging at the most precious place, or you might disagree with whether the most precious places are the circumference and the center, and you might disagree about fire being the most precious thing. But if you accept those three premises, then one should conclude that the fire is at the center of the universe. This is a syllogism. Okay, and interestingly, you're going to see similar arguments being used by people like Kepler and Copernicus later on. Copernicus is going to say the sun is the most important thing, and that is why it belongs at the center of the solar system. So they're going to resurrect some of the Pythagorean arguments. Another reason that these are Pythagorean arguments, or Pythagorean arguments that Aristotle is going to disagree with. Okay. Another argument that he provides, or that Pythagoreans provide, is that they say the most important part of the world is at the center, and fire can guard the most important thing. He calls it the guardhouse of Zeus, and therefore fire must be at the center. Again, this is an argument based on where things belong based on the importance or the preciousness of that thing. How does Aristotle argue against this perspective? Well, this is at the top of page 31, and here he says, well, let's suppose, just for the sake of arguments, that precious things often do lie at the center, but he says oftentimes the most precious things do not lie at the center of an object. So if we think, for example, of animals, he uses the example of animals, the most precious organ is the heart. And the heart is not at the geometrical center of an animal. In fact, the geometrical center of a human being is basically the belly button or the navel. So that's a case where the most precious thing, the heart, is not at the most precious or at the center of the object. So that's a counter argument that Aristotle provides against the Pythagoreans. Okay, let's move on to his point 2, the motion of the earth. This is on page 31. The motion of the earth, he says there's really no general agreement on whether or not the earth is moving. The Pythagoreans, he says, think that the earth moves about the center. So this is related, if the fire is at the center, they believe that the earth is going around the center. And the reasons that the Pythagoreans give for this is that if there are several counter-earths, perhaps, then they can obstruct sunlight from falling on the moon, and this accounts for there being more eclipses of the moon than eclipses of the sun. Now, I don't understand exactly how the Pythagoreans derive this conclusion, but they seem to be saying that the experimental evidence regarding the frequency of occurrences of lunar eclipses can be better explained if the Earth is moving around this central fire than if it is not. So I would have to, I suppose, see a more detailed version of the Pythagorean argument in order to assess this. And then Aristotle also mentions that that Plato, he doesn't use the name Plato, but he says Plato argues not that the Earth is moving around the center like a planet, but rather that the Earth is located at the center of the world, but it's spinning around its own axis. This is what Plato writes in his famous book, the Timaeus. And you might remember that Plato is one of the teachers of Aristotle. So Aristotle disagrees with the Platonic view of the spinning of the Earth about its own axis, and he disagrees with the Pythagorean view that the Earth is moving around a central fire. Okay? And then finally at point 3, Aristotle talks about the shape of the Earth. He says some people believe that the Earth is spherical, but not everybody. There are some who believe that the Earth is flat or drum-shaped. And so he says, what kind of evidence do these people who believe that the Earth is flat give? Well, he says, these people argue that if you look out at the horizon, so if you're out on a boat, you look at the horizon looks flat. And so it is. These are very similar to the kind of arguments that you'll find in modern flat Earth kind of argumentation. So if you look at Hendry's famous book, The Greatest Lie on Earth, which he's a modern day flat earther, he will claim that he will use similar kinds of arguments as the ancients who believed that the Earth was flat. So there were flat earthers back in the time of Aristotle, and there are flat earthers today. Nonetheless, many people believe in the sphericity or the roundness of the Earth. Aristotle was one of them. How does Aristotle deal with these kinds of arguments? He doesn't go into great detail here, but he says that although he agrees that the horizon does look flat, so it looks as if we're standing on a flat surface, he says the real reason it looks flat is because the Earth is very, very large. So there is curvature to the horizon. It's just very difficult to detect with your eyes. Okay, so let's jump ahead to the next section here. This is at the bottom of page 31, and he asks the question, why is the Earth at rest? After all, he says, if you take a little bit of Earth, so Aristotle's going to argue that the Earth is sitting at rest at the center of the world. But here's a difficulty, he says, that must have occurred to everyone. He says it would indeed be a complacent mind that felt no surprise that while a little bit of Earth, think about a rock that you lift up, let loose in midair, moves and will not stay still, and the more there is of it, the faster it moves, the whole Earth, which somehow is free in midair, should show no movement at all. Yet here is this great weight of Earth, and it is at rest. So he's pointing out that his claim that the Earth is sitting still does at first blush seem a little bit strange. After all, when you pick up a rock, it falls down. But here you have the Earth, which is sort of floating there, and why would it be floating there? Why wouldn't it fall? This is a reasonable concern that he brings up. What holds the Earth itself in place? And he says there are many solutions that philosophers have come up with over the ages, and because this is a very notorious and difficult problem, some of the solutions are notoriously absurd, he says. So now he goes on to talk about some of the ideas that people have for explaining why the Earth doesn't fall. You might put it that way. So first of all, he talks about Xenophones of Colophon. This is the first full paragraph on page 32, and Xenophon claims that the Earth pushes its roots down to infinity. That is, it goes, if you were to dig down into the Earth, it would be Earth as far as you go. There is no end of the Earth. So it pushes its roots down to infinity, and this way Xenophanes can avoid seeking a cause of the support of the Earth. Because after all, if it keeps going Earth all the way down, you don't need to have anything holding it up. Now, Empedocles, another thinker, and Aristotle for that matter, reject this. Aristotle does not believe, by the way, that there can be an actual infinity appearing in nature, and you would need to have an infinite amount of Earth going downward in order to agree with the view of Xenophanes. So let me say something else about this. This is an interesting topic that comes up several times in Aristotle. So we've been talking about Xenophanes' theory that Earth is, you might say, infinitely deep. So I'll just talk about this for a minute because this is an interesting kind of argument that is used in one form or another even today. Okay, so Aristotle disagrees with that. And part of the reason Aristotle disagrees, because he says there can be no actual infinity. In nature. What does he mean by this? There can be no actual infinity in nature. Well, he means that you can have potential infinities. Potential infinities. Now, what do we mean by a potential infinity as opposed to an actual infinity? Well, a potential infinity is this. Let's suppose that you were to count up to 100. Well, you can count higher than that, but you haven't actually counted higher than that. You can count to 1,000,000. That'll take a long time, but you could potentially count higher than that, but you haven't actually counted higher than that. So when you think about mathematics, there are potentially an infinite number of numbers, but until you actually count them, they don't truly exist. So there's a potential infinity there, but not an actual infinity. Likewise, if you were to take a piece of material and you were to break it in half, and you were to break it in half again, and you were to break it in half again, at each time you have a finite number of parts, first 1, and then 2, and then 4, and then 8, and so on. You can potentially break that into an infinite number of parts, but you never actually break it into an infinite number of parts. So he makes a strong distinction between potential infinities and actual infinities. And Aristotle believes that there are no actual infinities in nature, though there are potential infinities. And if you look at Xenophanes' theory, it seems to claim that there is an actual infinity, in the sense that the Earth goes down and down and down actually, and it actually has no end, because he uses that to claim that that's what supports the Earth. And that's the kind of thing that Aristotle would strongly disagree with.